Welcome back to Science with Miss Dubois. Today we're talking about density. That's me, Miss Dubois, so let's begin. Density is the amount of mass in a given volume. In other words, it's the amount of matter inside a limited amount of space. These two definitions are saying the same thing. The amount of matter is referring to the mass in the previous definition, and in the other word's definition, the limited amount of space, that's referring to the volume. And these definitions and these words will make a lot more sense when we define them later on in the video. Density is something that can be calculated, and it has a specific formula. Its formula is density equals mass divided by volume. And this formula can be represented in different ways. Density equals mass divided by volume, or mass over volume. Mass being in the numerator and volume being in the denominator is equal to mass divided by volume, which is also equal to m over v. M standing for mass, v standing for volume, which is also equal to grams over centimeters cubed. This is how we represent the density of solid objects. And then finally, grams over milliliters is how we represent the density for liquids. Let's go over some key terms. Mass is the amount of matter in a given object, and this is always represented in grams. Volume is the amount of space something takes up, and this can either be represented in centimeters cubed, this is used for solids, or milliliters, which is used for liquids. And then matter is anything that has mass and takes up space. There are patterns between the states of matter and density. Denser materials tend to have particles closer together, and less denser materials tend to have particles further apart from each other. So, for example, solids, where the particles are closer together, tend to be a lot more denser compared to gases, where the particles are far, far away from each other. And we can see this pattern in the visual right here. In solids, the particles are super close together, and then as we progress to gases, the particles are much further apart, taking up much more space, even though there is the same amount of mass. That is why the density in gases is much less compared to solids, because the same amount of particles are taking up more space, therefore creating a much lower density. Here we have two boxes, box A and box B. Box A and box B have the same amount of volume, but the particles in box A are much further spaced out compared to the particles in box B. So that tells us that box B is denser than box A because of how tightly packed the particles are. So density is a physical property. A physical property is something that can be observed or tested without changing the identity of the matter itself. And basically what it does is it helps us define what matter is or identify what matter is or help scientists build materials based on their properties. Now, a big thing about physical properties is that they don't change at all, and density is a great example of it. It's very similar to how authors would use characteristics to describe the characters in their books. So let's describe me. I have brown curly hair, I have a roundish nose, I have thin lips, I wear glasses every single day, and I wear a gold necklace every single day. These characteristics about myself don't change, like physical properties or density don't change. Now, density is a physical property, as mentioned earlier, because it doesn't change. Also, every object or every piece of matter has its own unique density, which really helps us identify what the material is because of how unique density for every little bit of matter or every new substance is. A great example of this is that pure water's density is 1 gram per milliliter, and that is so unique for us to know, and it's really important for us to know because that's how we can identify that water is water. So temperature and density have a really unique relationship. Heating up an object actually causes the density of an object to decrease. The reason why is because now the object is taking up more space, or the particles in the object are taking up more space, therefore causing the relationship between the mass and the volume to change. And that's what causes the density to decrease. Colder objects tend to be denser because the particles are closer together, taking up less space, therefore increasing the density. And it's basically the same amount of mass, just slightly different volumes. And that is why cold air is denser than warm air and cold water is denser than warm water, because of this relationship. Basically, hotter objects are less dense because they are taking up more volume, and colder objects are more dense because they are taking up less volume. It's kind of interesting and kind of weird, all at the same time. This idea of cold water sinking in warm water kind of explains why things float or sink. Basically, if something is less dense than whatever it's being compared to, meaning that the value of the density of an object is lower than the object's density or matter's density it's being compared to, it will float. Something with a lower density will float in an object that has a higher density. Now, if something has a higher density of whatever it's being compared to, meaning that number is greater, then it will sink. Kind of the same idea. Basically, we can see this with water. Anything with a density higher than 1 will sink. Anything with a density lower than 1 will float. And that's the quick introduction on density.